These are the notes for Algebra 2, Section 7.4, Part 3. We're looking at graphing logarithms. And the method that we want to use for graphing logarithms is one that we can do by hand, and we'll see how it works. Now, before we do that, we need to talk about the parent graphs for logarithms. Now, I am only showing you a picture of a logarithm for when b is greater than 1. Now, it says here that log base y equals log base b of x is shown for when b is greater than 1 and between 0 and 1. This is the one that I'm not showing you. We will see how it works a little bit later on, but I want to just give you a clear idea of what's going to be happening first. Because log base b of x and y equals b to the x, right, the exponential function, are inverses, the logarithm graph is a reflection of the exponential graph along the line y equals x. So now let's look at what that means. Here's our line, y equals x, right? This is y equals x. And we can see this line. Now up here, we have y equals b to the x. That's this line. Down below, you can see we have y equals log base b of x. Okay? So you can see along this line, y equals x. My logarithm graph is a reflection of my exponential graph. That's going to be pretty useful because that gives us an idea of what it's kind of supposed to look like, since logarithms and exponentials look about the same. Now note that the y-axis in this case, the y-axis, is a vertical asymptote. Right? This y-axis is a vertical asymptote. On the exponential, the x-axis was the vertical asymptote. Now remember, the asymptote is this imaginary line that the graph cannot touch or cannot cross. So for a logarithm, the graph is not going to be able to touch y equals 0. That means that the domain of my logarithm, you see my x values, has to be greater than 0. And the range is all real numbers. Now, that is exactly the opposite of the exponentials. You remember the exponentials, the domain was all real numbers, and the range was y is greater than 0. In this case, the domain is x is greater than 0, and the range is all real numbers. They flip-flopped. Now, let's see how we can actually graph these things. All right, we're going to graph a couple of different ones. Let's start here. We want to graph y equals log base 2 of x. And the way we want to do this, we want to start by plotting some easy points. All right, let's just remember what a logarithm is. When I say log base 2 of 1, for instance, right? Log base 2 of 1, we're asking ourselves, what power do I raise 2 to get 1? And the answer to that is 0. So when x is 1, y is 0. Let's look, if we had log base 2 of 2, again I would be asking what power do I raise 2? What power do I raise the number 2 to get 2? And the answer to that is 1. So when x is 2, y is 1. We'll do one last one here. If I have log base 2 of 4, again I'm asking myself, what power do I raise the number 2 to get 4? And that is 2. So when x is 4, y is 2. Let's go ahead and plot those points. 0, 1, so here we are, or 1, 0, I'm sorry. 1, 0 is right here. 2, 1 is right here. And 4, 2 is right there. Now, we're going to move from left to right, right? Drawing a curve that starts just to the right of the y-axis and moves up through the plotted point. So we're starting just right of the y-axis and moves up through the plotted points. Gives us this graph. Alright, so we figured out a few convenient points. The points that we pick do make our life a little bit easier. We want to pick something that will be easy to find the exponent for. We plot those points and we draw our curve. All right, let's look at the next one here. We're doing y equals log base 1/3 of x. Now we want to do the same basic idea. Now, we ask ourselves, all right, log base 1/3 of 1. What power do I raise 1/3 to get 1? I'm getting a little ahead of myself here because the answer is 0, but we want to get 1. What power do I raise 1/3 to get 1? The answer is 0. So when x is 1, y is 0. What power do I raise 1/3 to get 3? And the answer to that is -1. Because in order to get 1/3 to become 3, we have to take the reciprocal, which means we raise it to the negative first power. So when x is 3, y is -1. Last one we'll do here. Log base 1/3 of 9. What power do I raise 1/3 to get 9? The answer to that is -2. 1/3 to the negative second power is 9. So we have 3 points. Let's go ahead and plot them. We have 1, 0. Now my scale here is 1 on the y-axis, but it's counting by 2's on the x-axis, so I need to keep that in mind. I have a point at 1, 0, which is right here. I have a point at 3, -1, which is right there. And I have a point at 9, -2. So 2, 4, 6, 8, 9, -2. Now, starting from left to right, I want to, before we get there, the y-axis, you should know this, is an asymptote. Right? It's that line that this can't cross. Now, from left to right, we want to draw a curve that starts just to the right of the y-axis and moves down through the plotted points. So we're starting just to the right of the y-axis. We're moving down through the plotted points. Gives us this graph. Now you'll notice we're moving downwards this time. In example A, we are moving upwards. The only difference between example A and example B is that the base is different. All right. Here, the base is 2. 2 is bigger than 1, so B is greater than 1. Here, the base is 1/3, which is between 0 and 1. So if the base is between 0 and 1, it's upside down. It's moving downwards. Right? So we can tell just from looking at the base if we're going to be moving upwards or downwards. All right, we have one last example we're going to do. Now on this example, we actually want to graph the equation, then we want to translate it. Now translating, that's just when we move the graph around. We don't change the size of it. But we're going to start the same basic way. We say, all right, I have log base 3, and what I want to do, notice what it says here. I want to plot some points from the parent function y equals log base 3 of x. We want to do that because life will be easier if we do it that way. So, log base 3 of 1. Log base 3 of 1 is 0. Remember, what power do I raise 3 to get 1? And that is 0. We have log base 3 of 3 should be 1. What power do I raise 3 to get 3? The answer is 1. And I have log base 3 of 9. What power do I raise 3 to get 9? The answer is 2. So I started off by just looking at log base 3 of x. I ignored the minus 1. I ignored the plus 2. I ignored those for right now. I'll deal with them in a minute. At the beginning, though, I'm going to just plot these 3 points that I found. Again, my y-axis is counting by 1s. My x-axis is counting by 2s, so I want to keep that in mind. I have a point at 1, 0. So there's a point at 1, 0. I have a point at 3, 1. So here's 3, 1 right there. And I have a point at 9, 2. So 2, 4, 6, 8, 9, 2. Now, I plotted my points. Here's where things get different. I am not going to draw a curve here, right? Instead, I'm going to translate my points up to and to the right 1. All right, I'm going to translate my points up to and to the right 1. All right, so notice what's going on here. This plus 2 makes me translate up 2. This x minus 1 makes me translate to the right 1. All right, so it's kind of similar, right? We have log base 3 of x minus h plus k. We've seen this before. Again, we have minus h, so we have to switch h and k. We have to switch the sign for h to plus 1, and k stays the same. All right, so it's exactly the same movement. That means that whatever number we're lumping with x, we switch the sign of. That's why instead of moving to the left 1, we move to the right 1. Now, using that, we're going to translate these points. So, let's look at our first point here. My first point is at 1, 0. We are going to move it to the right 1 and up 2. Gives us a new point here, right? Right 1, up 2. The next point, we're going to do the same thing. We're going to move it to the right 1 and up 2. And our last point, same move. Right 1, up 2. Gives us our new points. Now, my graph goes through the points 2, 2. Right, I'm looking at my red dots now as opposed to my blue dots. My red dots are my new ones. I have a point at 4, 3. And I have a point at 2, 4, 6, 8, 10, 4. Those are my new points after I've translated it. Now here's a tricky bit. My asymptote was originally at x equals 0. But I translated everything over 1. That includes my asymptote. So my asymptote was at x equals 0. Now my asymptote is at x equals 1. So the graph's asymptote is x equals 1. Or 1, depending on how you feel. So let's draw a line that connects these guys. It's the base is bigger than 1, so it's going to be growing. There's my graph. Now the domain is x is greater. Whoa, that doesn't look like greater at all, does it? X is greater. Still doesn't look like greater. I'll figure it out at some point. X is, that's better, greater than 1. Not by much, but it's better. The reason why x is greater than 1 is because my asymptote translated 1 to the right. Notice my asymptote can't translate up or down, right? Because it's a vertical line. Vertical lines can't translate up or down. They can only translate left or right. My range is still all real numbers, right? The range is always going to be all real numbers.